Hey everybody, Rob Mayville, Novi Math Tutor here. Do another calculus problem from Calculus 6th edition, Larson. We'll do cross-section volume today. Let's see what we got. Number 55 in my book. Let's give it a roll, see what happens. So we have we've got a solid. The base is bounded by a circle. Circle radius 2, center 0, 0. And our cross sections that are perpendicular to the x-axis, just down, are in the shape of a semicircle. Okay, so this would be like half of a sphere. Let's see, so I'm going to draw the base over here, go 2 each way. Just a rough sketch. Okay, and then I like to draw the perpendicular cross section. Put that in red, I guess. Here's an example one. Perpendicular to the x. That would be the bottom. The bottom of the semicircle cross section. Put that over here. It's the bottom, or the diameter, I guess you could say. Cross section. So if we were to take that cross section kind of out of there, it would look something like this. What I just drew on the graph is this bottom part of the semicircle. Okay. And so we're going to have to find volume here. We're going to do that. Let's switch back to white real quick. To do that, we're going to need the area. It's the formulas from A to B for the area formula, the cross section. All right. So take that off to the side. The cross section is a semicircle. And the formula for that, there's a general formula. It's going to be pi r squared divided by 2. It's a semicircle, cut it in half. However, we don't want our formula in terms of r. We need it in terms of x. So we got to figure out how can we write that radius of that semicircle in terms of x. Well, if you notice, now you don't want to use that whole thing there. Normally with problems like this, you're kind of doing an upper minus lower. You get the length of the entire red bar. However, in our case, we only want half of that bottom. We want the radius, not the whole diameter. So we're not going to do an upper minus lower. Oh, just a side thing, in case you don't see it, there is an upper and lower graph there. The upper, if you were to get y by itself, right, subtract over the x squared. I'm taking the original value, the base. Solve for y. Square root both sides. Something like that. And that gives you the two semicircles. The plus version is the upper half, and the minus version is the lower half of the circle. All right, so if we did need that entire diameter, you could do upper minus lower. You could do the positive version of the semicircle, and then the negative version. Subtract those two. But we don't want upper minus lower. We don't want the entire bottom there. We just want the radius. We don't want the diameter. So what we're going to have to do is just do half of that. So if we just need this height here, that length right there, that's just the function height. What I can do is substitute that in for r. You can go pi, instead of r, write that function, 4 minus x squared. But then you got to remember to square the radius. Like that. Simplify it up a little bit. The square root and square root is just going to cancel out, right? So it's going to be pi over 2 times 4 minus x squared, like that. And so we can carry that over. And I like separating out the constant because it's a good habit to get into. Just always pull that out. Oh, but we already have. No, this one doesn't have pi. My bad. I'm thinking disk washer. There's no pi in front here. Right? All right, so we got pi over 2 pulled out. And it looks like our circle goes from a -2 to a +2 as we slide that red bar across the circle from left to right. And then I can put the remaining part of that area function in here, 4 minus x squared dx. Like that. There's the setup. I think you shouldn't have too much trouble finishing from there. Like I said, if you got any in earlier videos, got any questions, just send me a comment. And if it's a little more involved, we can maybe set up a session and meet for an hour. Just give me a text or a call, 704-451-9998. Take care. Have a great day.